In this video, I'll show you how to solve the ALEKS problem called predicting the compound formed by two main group elements. This problem is going to give you the names of two elements. You have to decide what type of compound those two elements will form and then give the formula for that compound. And we're going to start by predicting the type of compound formed by the two elements. There are three different options that we have here: ionic, molecular, and neither. And the type of compound that's formed is going to be based on the type of element that we're dealing with. So an ionic compound is going to be formed when we have one element that is a metal and the other element is a non-metal. So metal plus non-metal is ionic compound. A molecular compound is going to be formed when both of our elements are non-metals. So if we have two non-metals, that's going to be molecular. And then neither, we would choose neither if we had two metals. The only type combination that will not result in a compound is a metal plus another metal. So what we want to do is identify each one of these elements as either a metal or a non-metal based on their location on the periodic table. To do that, we're going to imagine that line through the metalloids, this line that divides our metals from our non-metals. All of our metals are over on the left-hand side of that line, and our non-metals are on the right-hand side. For the first problem, we have chlorine and cesium. Chlorine is right here and cesium is right here. So this is a metal plus a non-metal, which means that this is going to be an ionic compound, metal plus non-metal. For our next example, we have carbon and chlorine. Carbon is right here, chlorine is right here. There's that line. Both carbon and chlorine are on the same side. They are both non-metals. That means this is going to be a molecular compound. And our last one, we have oxygen with barium. Oxygen is a non-metal, barium is a metal, so this is another example of an ionic compound. Now, if we have an ionic compound, we need to predict the formula. If we have a molecular compound, we also need to predict the formula. If you were to choose neither, then you wouldn't need to predict a formula for that particular compound. We're going to start with the ionics because those are going to be easier for us to predict. To predict the formula for the ionic compound, we want to think about the charges on the two elements if they were going to be ions. And I'll give you kind of a reminder. The charge of the element is based on its location on the periodic table. So going back again to find these elements, chlorine is right here and it is in the -1 column, so I'll give it its charge. Cesium is right here and it is in the +1 column, so I'll give it its charge. We want to combine these two in a 1-to-1 ratio. Remember, our goal here is to put them together in a way that the positive charges are all going to cancel out or balance with the negative charges. When we're writing the formula, remember that we always want to write the cation first and the anion second. So first, write the cation, and then second, write the anion. Let's do our other ionic compound. We have oxygen and barium in this one. Oxygen is located right here, so that's a 2- ion, and barium is right here, so that makes it a 2+ ion. We want to combine these together in a way that the positive charges balance the negative charges. 1-to-1 ratio is going to give us the correct combination. Cation first, anion second. And ALEKS does give you a little bit of hint here. When we're writing the compound, write it with the fewest total number of atoms. So if you had been tempted to write Ba2O2, don't do that. You want to reduce that down to the smallest total number of atoms. For our molecular compounds, carbon and chlorine, this is not based on the cation or the anion, the charges of the ions. Instead, it's based on bonding. ALEKS does give us a hint. All chemical bonds are single bonds. So what we're going to do in this situation is put the carbon and the chlorine atoms together in a way to make a molecule. And to do this, we want to be thinking about the Lewis dot symbols, or the number of valence electrons for each compound. So I'm going to change my numbering on the periodic table, and I'm going to change it to reflect the number of valence electrons. Our carbon atom, because it is located right here, that means the carbon atom has a total of 4 valence electrons, and our chlorine atoms each have a total of 7 valence electrons, which is going to look like this. And I'm actually going to redraw down here. What we're trying to do is combine the carbons and the chlorines in a way so that all of them have paired electrons, no unpaired electrons. And so what I'm doing is I'm matching up every chlorine atom's unpaired electron with one of the carbon atom's paired electrons, and we can use as many carbons as we need, we can use as many chlorines as we need. So this is the structure that I've come up with. Looking at that structure, I have CCl4. And in terms of how we go about writing these, typically we write the central atom first in the molecular formula, and then we write the outer atoms second in the molecular formula.